Um, our next speaker, which I'd like to welcome to the podium, is Dr. Happy Sithole. He's going to talk to us about the contribution of high-performance computing and modeling for industrial development. Dr. Sithole is the director of the Center for High-Performance Computing at the CSIR. He completed his PhD in material science at the University of Limpopo, focusing on the electronic and atomistic simulation of iron sulfides. He has applied high-performance computing to solve problems in mining industries and nuclear power plant designs. Welcome, Dr. Sithole.
Good afternoon. Thanks, Dylan, for the introduction. As indicated, my talk is going to be focusing on the contribution of high-performance computing and also modeling for industrial development. So I'm going to address this topic looking at what the CSIR can offer to industry and basically to the country in this initiative. So first of all, I think it's important that one look at the strategic context. And I think with the timing of this talk, a lot has been said about artificial intelligence, machine learning. I think up to this stage, we are convinced that the world is looking at these technologies seriously. And if you look at what is happening globally, nations are gearing up and putting strategies on how things like artificial intelligence are going to dictate their competitiveness as the nations. So there are those debates. But also at the same time, if you look at some of the discussions also, there's fear about these technologies again. If you following the discussions like for Elon Musk and Mark Zuckerberg, whether this should be regulated already, there's some fear. So I think those are some contexts that we have to look at, the benefits and also the challenges that these technologies bring. And also I think the second point is very important. Coming from the CSIR, we are looking at this focus now where we're looking at the industrialization as our strategy as an organization and how the opportunities of high-performance computing can be able to bring in another dimension for manufacturing. And this coming into what we call the virtual prototyping. So how do this come together and form our strategy? But again, I think as we look, we can see the success of other nations, that the countries that have adopted high-performance computing and all the necessary technologies, we can see the advancement from this country. So I think those contexts drives us as an organization to really propel the use of high-performance computing and modeling and simulation to assist industries. So that will be my focus. And the first thing is, what is it that we propose? What is our value proposition? What I can say is that with the Center for High-Performance Computing, the CSIR is 72 years old. The Center for High-Performance Computing, we are a 10-year-old organization. And we can pride ourselves with experience of supporting industry during this period. And what we do is we understand that to take these tools, each and every client is different, and we recognize that uniqueness, and hence we work closely with each and every customer to look at where can we be able to realize the return on investment if you adopt high-performance computing. And the other thing is obviously to reduce the barrier for innovation through the virtual prototyping. And when we do that, we believe that when we have got an idea to get to a product, in most cases, people are distracted by the issues that come for you to be able to validate this idea to get to a product, which is the prototyping. And normally during that period, a lot of ideas just fall off, which we can call the value of death. And this is the area that we believe high-performance computing can be able to contribute. And in that way also, as an innovator, then you minimize the risk for you to be able to get from an idea to a product. So those are our value proposition. And basically, this just gives you an idea on how the effort that one has to put in terms of the resources. If you have to get into an industrial product, you can see that the effort gets higher in terms of the resources, your time, and this is what normally that takes people away and take them off the ideas. So what we offer here is that because of the experience of working with industry, we already have got some contracting models that we can work with big companies and small companies. We have got, for experienced users, those who already have got engineers or scientists in their organizations. They only need CPU cycles. We can be able to provide that. Some of the companies come to us. They have got software that they would want to use. We can assist them to be able to use that optimally into high-performance computing systems. Like you find that one can be able to use this software just on their desktop, but if you really want to take advantage of massively parallel systems, then the challenges come, and this is where we have got the experience in doing that. And some industries also look at building their own HPC systems, and they don't know where to start because we have got so much technologies. What is the right technology that I can be able to use in my industry to be able to optimize our systems? And this is something that we can be able to provide. Some clients, you are sitting with a problem, you had that it can be solved by computing, but you don't even have expertise, you don't even have software. So basically, it's an end-to-end solution that you're looking for, and this is some of the things that we can help you on. And we also have got what we call a gradual on-ramp. In this case, is you don't have expertise today, but you're looking at developing this expertise in future, and we can be able to work together with you that by the end we finish, then you have got this expertise in-house. So these are some of the things that we can be able to offer to industry. So behind all these things, immediately when we get into AI, you get to machine learning, you can run it on a single desktop. It still doesn't give you that competitiveness. The real competitiveness comes in when you have got massive parallel processing, and you can be able to do this task within the shortest possible space. And what we offer in South Africa is we have got leadership HPC system. And this is the machine that we installed, and it was in 2015, 2016. So in different phases. And what you see there is the number of processors that we have. And at the moment, this machine, it can be able to provide the processing capability of 1,029 teraflops, which is 1.29 petaflops. Basically, that tells you it's 1.029 times 10 to the 18 instructions per second. So for the task that was going to take you maybe a month on your desktop, basically now if you can be able to parallelize it in this machine, it can take you a couple of hours. So that for industry and for innovation, that's what we call competitiveness, because we can be able to make decisions quicker. But not just making decisions quicker, it also helps you because we can be able to take all aspects of your design into consideration and we can be able to have more accurate predictions. So it's about speed and it's about accuracy, and hence we invest in such systems. So this is the system that we call Lengao, and as you can see, the machine was launched, and it is ranked as 127 on the top 500 supercomputers in the world. And of course, awarded the fastest supercomputer in Africa. And so this is a world-class facility that we have available in this country and for access to industry. One thing that is very important is building these machines. You don't want to be putting them there and doing nothing. And as we can see, this is a machine that is heavily utilized, that at some point, you see that even touching almost up to 100%. So all the time, the machine is heavily utilized. And this just shows you again, I think here I normally just put this, and my team, they ask me, why do you keep on putting this one? This is when we were doing the upgrade, and you can see that at that time, the machine was not available. But immediately after the upgrade, you can see that there was a huge uptake of the system. But again, the other thing that we have, for industries, you have got industries in different areas, like your engineering, maybe industries in materials, different industries. You can see that the machine can be able to be used by different industries. We have got the earth sciences, bio, materials, we have got the engineering and astronomy. So it is designed to be able to solve most of the problems that you find in industry. So that gives you just that comfort. So coming back, I think the previous speakers have already talked about the challenges, especially what Peter covered. In industry, you know, in the design process, you start back of the envelope, and then you come up, build something, you test and fix. So in all these things, these are some of the things that we need high-performance computing for. And for an example, if I take this slide here, you look at the technology development, starting from your concept in this case, going all the way to the product. We have got a lot of theory here. We've got universities, we've got industry there. This is the role where high-performance computing comes in, because we can be able to provide you with the opportunity now to do the virtual prototyping. And that's where the high-performance computing can be able to assist different industries in moving from product to, from ideas to product. The other thing is that you have got an already operating plant. One of the things is that on an already operating plant, you can be able to collect data and to model the plant and understand on how the plant actually works. And this gives you an opportunity to be able to tweak some of the parameters so that you can be able to optimize. So it is in the design phase, but also in optimizing already existing plants, you can be able to use high-performance computing in that area. So what we actually offer in the CSIR, in this case, I showed you the HPC systems. We have got the applications, but the CSIR, we have got different capabilities in the domains, like from your defense, climate, materials, and fluids. So these are people can be able to do the modeling in all these areas. So what we actually combine is this expertise and the knowledge of the HPC systems is an area which gives you the differentiator, because you can have this knowledge of your different domains, but if you don't have the infrastructure, then you are not yet competitive. And even if you have got a big computer and you don't have the right expertise in terms of your domain, then still you are not competitive. So we give you the combination of that at the CSIR. So when we look at the market, we can be able to look just from the computing, just providing you with computational cycles. But the other thing, again, on the R&D contracts, from our domain expertise. But in the process also, what comes up here is some software development, and there has been some software that has been developed specifically for HPC systems and adopted by multinational companies. So that's what we bring in terms of the organization. The next slide just gives you some of the examples of the type of problems that have been solved with high-performance computing. You can see in this case where we're looking at the vehicle tire pavement interaction and the degradation of the road, and doing a simulation in this case. You can see the simulation that has been done by one of the team here at the CSIR. And this other example here is where you have got the fluid interacting with a structure and looking at a simulation of fluid structure interactions. We have got the expertise in those areas. And the other one here where you're looking at the different features, identifying different features, and you can be able to have many of these objects. And this other one here, again, is one of the big projects that the CSIR is contributing on the International Protocol on Climate Change, and the simulations are done on our computer here. And this just gives you a broader view of the different industries that currently we have been working with, some in the past, some currently. So basically in the country there is adoption of the high-performance computing. And it's a variety of industries, I mean, like established industries. Some of the industries are really like small industries. If you look at the triggerfish here, which is a small industry that's just getting into 3D animation movies. Before, we did not have any 3D animation movies coming from this country, but you can start seeing now the flow in that direction. So that's a broader range of industries. This is just one example on our petrochemical, and working with a petrochemical company here. You can see here below here, this is what the company could be able to afford to do. And in estimating reservoir, you're looking at the runs per hour on this side. And they could only do this just using the internal infrastructure. But we can see that immediately when we help them, then it really pushes that they can be able to do better prediction of their reservoir and also saving the time. So these are just examples that show you what high-performance computing can do, and I hope I was able to show you what are the offerings at the CSIR, and you can engage more with the team. We have got an exhibition stand there that can give you more into details into the parts that I talked about. So on that, I think this is just, again, another example on combustion. And thank you for your attention.